Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 7, Notes 1. In Unit 7, we start talking about the normal distribution. So the normal distribution is a bell-shaped probability distribution where you have a line of symmetry. It's a symmetrical curve where you have a line of symmetry down the middle, and that line of symmetry is the mean of your data. So if you've got a whole data set and your data set follows a normal distribution, meaning it's normal in shape, then your data set looks like this with this bell-shaped curve, and your line down the middle is the mean. Okay, so we've seen that mu before, that is the mean. Then from that mean out in either direction, we mark it by standard deviations. So if you think back to Unit 2, we talked about calculating a standard deviation of something. So we would calculate a standard deviation to know what the typical distance from the mean was. So 1 standard deviation away, 2 standard deviations away, or 3 standard deviations away in the positive direction. You can also go 1 standard deviation, 2, and 3 in the negative direction or to the left. The other thing about the normal curve is that it marks certain percentages. So within 1 standard deviation is approximately 68%. Within 2 standard deviations is approximately 95%. And then within 3 standard deviations is approximately 99.7%. And that is called the empirical rule, which is something we're not going to use too much in this class, but just so you know, there is a measurement, 68, 95, 99.7, that marks your standard deviations away from the mean, being your center. Now, this is the whole big formula that calculates your probability for standard deviation, but fortunately for us, we're not actually going to use this formula. This is not something that you have to be able to calculate or work with, because we have a table made and created for us that is going to teach us all about this formula, or not teach us all about that. It's going to tell us all the probabilities of this formula. So this table that you'll see, you're going to use this table a lot, kind of like your binomial distribution table. This is your normal distribution table, and we're going to talk about how to read that table today. So the normal distribution table has it's a table of that formula done for us for all these standard deviations away from the mean. So in a normal distribution, your mean is 0 and your standard deviation is 1. So you can standardize your values so that they follow this normal distribution. Mean 0, standard deviation of 1. And we're going to talk about how you standardize your values. The values that are in the table show the probability of the population, and it's always shaded to the left. So you can see, like, if I'm marking this standard deviation, the probability in the table that's given to me is marked to the left. The probability is found using a z-score, and we're going to talk about what z-scores are. Z-scores are how many standard deviations you are away from the mean. That's your Z. Okay, so Z-score comes from how many standard deviations you are from the mean. And today we're just going to practice reading this table. That's it. We're going to work more with Z-scores in future lessons, but today we're just going to practice reading the table. So, in example 1, it says use table A to find the probability given to find the probability given the value of Z. So we are given a Z-score and we are asked to find the probability. Now, on your table, you may notice that hopefully you have a paper copy of this. I handed them out in class, so hopefully you have that blue copy of your Z-chart or table A. If you look up in the upper left-hand corner, you should see that it's called table A. But your Z-score table looks like this. And if you notice, your Z-score table has 2 sides. It has a side for all negative Z's. See that negative 3.4, negative 3.3, negative 3.2, all the way down to negative 0, which we'll talk about. And then it has another side that has all the positive Z-scores. So here's the thing. Your mean marks the 50% line. So if your probability is less than 50%, that means it has a negative Z-score. because it's below the mean. If your probability is under 50%, that means the z-score is below the mean, which means it is negative, okay? So when I look at a z of negative 1.5, I want to flip to the negative side, and I want to go down to negative 1.5. Now you're probably wondering, what are all these values across the top? The values across the top are the hundredths place. So if I want negative 1.50, that means I'm at this first one, which is under the 0, 0. So this is the hundredths place of 0. So my probability there is 0.0668. 668. Sorry, my decimal point got a little less there. 0.0668. Negative 2.96. Let's look at negative 2.96. So negative 2.96 means I need to go to the negative 2.9 row, but then I need to come out to the 0.06 column. So my probability is this one right here. Okay, so that means this probability is 0.0015. So what that's marking is on your normal curve, if I were to draw a little picture here, because you're probably wondering, like, what does that even mean? I don't even know what I'm looking at. If I draw my normal curve, okay, with this being my mean, negative 2.96 standard deviations is out here. So here's 1, here's 2, negative 2.96 is like right out here. So it's that little teeny tiny piece of probability that I just colored in. It's that little piece. So if this is z equals negative 2.96, then this is p equaling 0.0015. Look at how small that probability is. That's why it's marking such a small piece of that normal curve. Okay, let's do the next one, negative 0.12. So negative 0.1 is where I'm looking, way down here. And then I need to go out to this is the negative 0.10, 0.11, 0.12. So this is my probability, 0.4522. So that basically just means that there's 0.4522 of a probability of being at this z-score, this far away from the mean or lower. You know, negative 0.12 is going to be barely below the mean. You know, it's going to be really close. So it's this whole section out here to the left. That's what that probability is marking. It's marking that whole section out there to the left. That's why it's a lot bigger, okay? Because as you approach 0, 0 is our 50% marker. If I'm not any distance away from the mean, that means I'm on the 50% line, okay? Now, what about positive z-scores? So if you're holding your blue chart, I want you to flip it over and look at the positive side. So here's my positive side. I'm going to look at letter D. I want the z-score of 0.89. So 0.8 is right here, all the way out to the right-hand side. This one is the 0.09 column. So 0.89 has a probability of 0.8133. Then the last one that we're going to look at right here is 3.2. So 3.2 and then 0, because there's nothing after it. 3.20 is 0.9993. Look at how big of a probability that is. If I moved that over 2 places, that's 99.93%. If I mark that on my normal curve, say my normal curve looks like this, here's my mean, I'm up to 3.2. So here's 1, here's 2, here's 3, and remember, it's marking probability to the left. So look at all of this probability that I'm shading in. Okay? 99.93% of our data is below the 3.2 z-score. That just means that I have hardly any data out here to the right, where my curve is going up to the 0. You know, it levels out at 0 up there. I have hardly any data. Only 0.07% of my data is above that 3.2 z-score line. Okay, so now let's go backwards. Now we're going to look at a p-value. This is your p, and I want to find the z given the value inside table A. So this is these are your p-values in the body of the table, That's what I'm looking at. Okay, so here's the thing. We talked about the normal curve already. You've got a bell-shaped curve. Your mean is marking the middle. 50% is up here. 50% is down here. Okay, so if I am looking at 84%, that means that I'm up here on the positive half. Okay, this is positive z's. This is negative z's. Because if I'm above the 50% mark, that means that I'm in the positive direction of how many standard deviations I am away from the mean. I'm moving up. If I'm below like 13% or 0.3%, I'm in the negative direction. Okay, so that's going to help you figure out where in the table you're looking. So this 0.8413, this is on the positive side of your Z chart. It's above 50%, so it's on the positive side. So now I'm looking in the body of the table to find that value. The p-value is in the body of the table. So if I look, here's 8186, here's 8212, I'm getting closer, is 8219, 8315, 8340, 8389, here it is, 8413. So now find the z-score associated with that, and it goes with this and that. Your z is 1.00. So again, I'm working backwards. I'm looking in the body of the table to find the z that goes with it. Let's look for 9474. So 9474 is going to be, here's 92, here's 93, there's 9495. I need to go a little less. Here it is, 9474. There's my value. So here's my 1.6, that's the ones in the tenths place, and then my hundredths place is the 2. So this is z equals 1.62. Let's look at 0.6406. 6406 is going to be closer to the top because it's not that far above the 50. Remember, 50% is our middle ground. So 6406, I see it right here. So that's the one I'm looking for. Now find the z that goes with it. 0.36. 0.36. Let's look at 0.9997. 0.9997 is going to be way down here. There's 9994, there's 9996. Here's 9997. Here's another one, 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 here's another one. You are going to choose the first one that you see. When you have repeated values out in the extremes, you want to get as close to the mean as possible. So you're going to choose the first one that you see, which in this case is 3.39. So my z is 3.39. Now let's look at the 13%. So here's the thing about the 0.1314. 0.1314 is below 50%. So that means I need to flip my table over and look at the negative z-scores. So here I've flipped my chart over. Now I'm looking at the negative z-scores, and I'm looking for 0.1314. 1314, here's 1357. So I'm up too high. Here it is, 1314. The negative side is a little bit tricky because the probabilities almost go backwards. Because if you think about it, you're reading the graph from the middle to the left. It's like you're reading backwards. So what's the z that goes with it? You've got negative 1.12. Okay, let's look for 0.0038. 0038. Here's 0060. Here's 0045. There's 3435. Here's 363738, and there's only one of them, so that's it. And my z that goes with it is here and here. That's z equals negative 2.67. Okay, so again, your z's are out here on the row. The z's are like the headers. So you've got your row headers and your column headers for the hundredths place. So look for your z-scores out there, and then the probability is what's in the body of the table. Okay, now let's talk about finding something that's closest, because you might not find an exact value within your table. You might have to get a little bit more creative or look at something that's closest to it or whatever. So find the value closest to 0 given the value inside table A. So this again is a p-value. I'm looking in the body of the table. And the question is, what is z? Or I should say, what z is closest? Okay, that's what you're looking for. So again, these two up here are below 50%. So that means I'm on the negative side of the z-score chart. So here I am looking at the negative side of the z-score chart. You can see all my negatives down there. Let's look closest to 0.0021. So if I go closest to 0.0021, here's 0.0025, 24, here's 23, 22, 0021. Okay, and I've got 2 of them. So which one is closer to 0? So if I look at the z-scores, I have negative 2.8 and the 6. You can do negative 2.86 or you could do negative 2.87. Which one is closer to 0? It's this one. So negative 2.86 is my z-score. Sorry, I should have written z equals. How about this 0.0008? So 0.0008, I see this one, this one, this one, and this one. The one closest to 0 is that negative 3.14. How about the 0.9977? 0.9977 is going to be greater than 50%, which means in the positive z's. So here's my positive side of the z-scores. You can see all the positives down there. 0.9997 is all of these. 9997, all of these ones. We looked at this one already, I think. So we're at positive 3.39. 0.9992. 0.9992 is this one, this one, this one, and this one. The closest one to 0 is that. That's 3.14. 3.14. I should have written z equals there, sorry. And then 0.9995, I've got this one, this one, this one, this one, this one, this one, a whole bunch of them. The first one that you find is the one that you want. That's the one closest to 0. So, because again, we want to be as close to the mean as possible. So 3.27. You can see that as your z-scores get farther away from the mean, you know, being 3 standard deviations away from the mean is pretty far. As they get farther away from the mean, you don't have much change in your probability. Going from 9988 to 0.9989, there's too many nines there, I can't say that. Going from this one to this one, I didn't increase by very much. These two are the same. These two are the same. These ones, I only increased by 1/10,000th. So as you get further out in these greater z-scores, your probabilities don't change a whole lot from one to the next because your curve is just so low down to that x-axis. All right, so now let's talk about the one that's closest to the given value. So again, we're looking at P. I'm going to pay attention to if I'm on the negative side or if I'm on the positive side. These 3 are on the negative side. These 2 are on the positive side because these 3 are less than 50% and these 2 down here are above 50%. So let's start with A, 0.3593. So if I look for 0.3593, here's 3557, here's 3594. I'm between those two values, but this one I'm much closer to. You know, your 3593 would be over here somewhere. You're much closer to this one, so I'm going to call that my z-score. Negative 0.36. Z equals. How about 0.0118? 0.0118. I'm just looking in the body of the table. Here's 0.0116. Here's 0.0119. 0.0118 is going to be closer to that one. So the z-score that I want is negative 2.26. How about 0.296? 0.296. Where am I? Here's 0.268. 0.287. There's one that's pretty close. 0.294. It's between this one, the 1.90, and the 1.89, but it's closer to 1.89, negative. So that z equals negative 1.89. Okay. Then for these two, I'm on the positive side, so I need to flip my chart over. So flip your chart over to the positive z-score side. Look for 0.9511. 9511. Here's 9505. Here's 9515. 9511 is going to be closer to this one. So I'm at 1.66. 1.66 for my z-score there. And then 0.8355. 0.8355. Here's 8340. Here's 8365. 8355 would be closer to this one because it's only 10 thousandths away. This one, it would be 15 10,000ths away. Basically, you're looking at the last two numbers. Where does 50 fall between 40 and 65? 55 is closer to this one. So I'm at 0.98. That's the one that's closest. So, all right, that takes us to the end of Notes 1 for today. Hopefully that helps you read that z-score chart a little bit. Just remember those z-scores are on the outside, so watch that. Your z-scores are your row headers and your column headers, and then the probability is what's in the middle. So you're looking at a normal curve and how far away from the mean are you in your normal curve? So standard deviations going out, what's the probability that you're above or below that certain level of mean? Thanks for tuning in.